It's about, what, 1 a.m. for us?
Yeah.
2 a.m.,
Yeah.
something like this?
Sleeping time.
So please, bear with us. So as I said, the plan was to do mastering Git collaboration. And then the trick at the beginning was, the Git is the tool. What's really important is the collaboration. And then why do we need collaboration? Well, we thought we didn't need to cover it. And then after speaking to some of you, for the last few days, I thought, okay, maybe there's some principles we need to go back to and then maybe explain those. I'll try to go a bit faster so that we can cover. But if it's too slow, you just, you raise your thumb and you do it like this. Like this is, I want more so I can go a bit faster. All right, so the first thing I wanted to address is this. What's the name of the conference?
DevOps.
Yeah, you see the big DevOps in there? And I thought, well, there's not that many selected sessions. And then I thought, oh, that's a shame. And then I remember that I didn't submit any. And I guess we're not the only one. So I thought, okay, maybe we'll change a little bit this session. And then we will cover a bit more DevOps. So then we understand that DevOps is one of the key drivers for collaboration. And then that's what gets us to using Git. And hopefully that will make sense after the talk. And that will give you all the tools so that you can communicate within your company and make sure you push. Because if you're here, you're probably part of the innovators in your company. And that means you're the one that's like, we want to do better, we want to improve, but sometimes it's hard to have the right communication. So hopefully that's going to give you some of the tools, that's going to give you the vision, and then maybe some references that you can go and read. So then it's easier for you to make those changes. So first of all, you recognize that picture. That was an opening ceremony, I guess. And this is Raimund. Raimund's here to help me. And I'm Gael. I don't know if you've seen me before. We went to the session, the workshop that we did, which was 4 hours of DSC so that we don't have to do DSC again. Yeah. So a lot of things will be similar because we go through the same things. Like we want to manage infrastructure as code, and then we want to manage code. So there's some things that are very similar. Let me just go and maybe put that a little bit further away. There we go. Sorry for that. And it's even worse. It's still ringing. Oh, damn it. And the other way around. Is it better like this? Actually, maybe it is. No.
Still ringing.
Still ringing. Yes. Okay. So I think someone's going to come later maybe to fix that. Where was I? Yes. So the idea is it's the same principle. We want to manage things by code because it's easier. That was what we covered during the workshop. Doesn't matter if you didn't attend, but all the idea was managing code. It's easier than managing a GUI. And then the problem then is how do you evolve with that code? So the question I want to ask you is, this is a PowerShell conference, right? So why are we all here at the PowerShell conference? What's the goal, and why, especially why, companies are sending all of these people to attend this kind of event? Can you throw some ideas? What do they think they're going to expect from you?
Do more with less.
Automation. What did you say?
Do more with less.
Do more with less. Yes. PTSD in there. Yeah, do more with less, but what's the end goal? Why doing more with less? Say again? Money. Okay. Why money? Is it money? Yeah, but what do they get with money? Yes. You're getting closer. Stakeholder value. So
Business value.
there we go. Business value. That's what I wanted. So there's business value. And we're all here to maybe improve the business value. So from the same amount of money, getting more value out of it, right? So that's exactly what I want to address today. How do we do that? And it's not that difficult, and some of it will be, of course. So we are here, we all craft business value. That's what we're doing here, right? That's what we learn. We learn how to do that better. But that's kind of obvious that we're here for business value. Oh, this is Rob. So if you wanted to have a picture of the community award, I believe, this is him. He got it. He's a good friend. And I love his pictures, so that's why I use that one every time. And that's the kind of things they really say to me quite often. So yeah, so true. So it's business value. So business value, what it is, again, it's going to be quite obvious, is the contribution from you and your team that your organization finds valuable. Okay? And it's obvious, but it's not. And then you always have a manager that tells you, yes, we want you to do this, you to do that. And it's clear. And the next minute, it's a different thing, right? So it's probably for you to do the job and understand where to get it. So how to think about finding the value that you create. So it's always the same principle. You have your organization and you have the customer in one end. And your organization is trying to provide value to that customer. That's, sometimes if you're a charity, for instance, your value might be a service, or that could be something a bit special. But in general, it's about money. That's going to be difficult. So the idea is you've got teams contributing to create the value from within your company, your organization. You have a team A, a team B, another team C, and that's probably the one you work with. And they're all contributing and building things together that eventually create some value to the customer. And in exchange, usually the customer gives money back to the organization. And you're probably there in team C, and you're the one with the PowerShell skills, and this is where you are. So you're part of a bigger system where teams needs to collaborate and then create something bigger and bigger, adding up. And then eventually, in one way or another, maybe you're just managing a laptop, but the laptop is used by someone else doing maybe accounting, which is going to eventually do something, accounting firms or something like this. So you're contributing to the business value. But we create value doing what? And this is what you said earlier, automating, operating stuff, securing, managing data, if we put it widely, maybe doing some reporting. So we provide value that way. And we use PowerShell to do this. I would say most of the time, if you're here, probably that's what you're doing, in one way or another. So PowerShell is the enabler. But it's just the enabler. What do I mean by this? It's the enabler. Any clue? It's not the desired outcome. You're not there just to do PowerShell. PowerShell is just a tool. You could do that probably with other tools. Your company probably do not care what language you use. So bear that in mind. That's important, and especially when you think about this. And how can you, and that's the question, how can you produce more value and do more with less? You can put it in the same way. This is, produce more value. We're not going to pay you more, but you have to produce more. You have to be able to do more. So that's the question. So do you know how to produce more value? Do you have some ideas? Tell me. Don't be shy. Be more efficient. Reusable. Amplify. Sorry, say again? Lower downtime. Empower others. Okay, so there's a lot of ideas there, and then we will go to this. So we can ask the question maybe a bit more high level even. So what does it take to become a highly performant technology organization, right? Because every company is a technology company now. In some way or another, they all use technology to provide more value, probably with less expenses, right? So we'll go into a journey to find this. So do you know this book? Who's read Accelerate? One person. Okay, who's heard of it? 3, 4. Okay, who's been reading the Phoenix Project? Okay, there's much more. Okay, so the people behind the Phoenix project, if you look at the author, Jin Kim is one of them. And then this is the DORA at the time, DevOps, I forgot the acronym it is, but basically the organization that does the DevOps reports. And they looked into the science, which is, what does it take to be a high performer? And this is a very good book when you need to understand, what's the result of this research. So what does it take to be a very good, a Netflix or a good organization that does really good IT? That doesn't mean you need to do exactly the same thing, but we will get. They found there's a few areas that are, they've got, capabilities, measuring and culture. There's a few things that they realize high performers, they do the same kind of things. They have the same approach. And usually they also found out that low performers do have the same problems and implement the things the same way. So that means they found out in a scientific way that if you follow some practices and some concepts and you evolve the culture in some ways, the leadership in some ways, you will become a high performer. So there's 4 levers of transformations. So for me, it's the interpretation of what's in this book, and I will just give you a very quick tool set so then you can think about it in some ways. So there's different elements. There's a change speed, the efficiency, the collaboration, and the impact. If you remember the adjectives you gave me earlier about, how do you do this, they probably fit into one of these categories. So when you've got this, you can go and have a bit more details on what do we see in each of those. So change speed is, if you want to be able to deliver something, that means you need to change the code. You need to change something, right? The quicker you can do that, the quicker you can deliver something new. So what's important is to reduce the friction. So if you have something that gets in the way of deploying, for instance, you can deploy only once per quarter, it's going to be very hard to change quickly and to adapt to your environment. You will try to cram more things every time you have deployment. You need to have automated deployment to avoid this issue. So then as soon as you've finished doing some changes, if everything's okay, then you should go straight away to your deployment. If you think that's a safe thing to do, obviously, and there's some guardrails that you need to have in place. You need to make sure you can do deep work and not changing priorities every minute and a half. And then avoiding interruptions for that. Because a simple task that takes you an hour to do, if you have to split it in 3 times, then it will take you 2 hours to do it. Because every time you have a problem with remembering where you were into your development and things like that. And you need to have an architecture that is largely coupled, so then you don't, it's easier to make change in one part without affecting everything else. Obviously, that means you need to test things together, which is integration tests. Then you need to improve quality. High quality, less rework. That means if you do something, you make a change, you can quickly find out if there's an issue with it. Otherwise, it's high quality, you can go to prod, and then you're confident. That's something that you mentioned earlier. MTTR is mean time to recovery. So if you have a low MTTR, that means if you have an issue, you can recover quickly. And high MTBF, which is mean time between failure. Those are metrics very important for you to be able to assess, if you're improving or not. Maybe you're going in a way that you're trying to move too fast, and that's actually going against those metrics. So maybe you should stop, think, and improve those. You need to reduce waste. That was the efficiency that you mentioned earlier. Okay, how can we be lean? How can we avoid doing things that actually is not needed? When you're firefighting and then the priorities change, sometimes you just change to something and then you do it, and then you realize no one's been using it for the last 3 months. But it was very important and urgent 2 months ago, right? Everyone, I see a number of smiles, so I know it happens all the time. And then you need to optimize your efforts, which means sometimes you need to be aligned so that if you all scrum together to make something happen, then it's better than having someone working on it on and off for 2 years before you can deliver. So you need to make sure that when you start something, you can finish it off. And then the strength is in team. Be careful when you take on work and then you have different people assigned different work centers. I call it work centers. You need to co-create. You need to do something together because this is the way you communicate better and you manage the knowledge, institutional knowledge, with your team. You need to standardize. Your first step is to agree on what to do and how to do it. Because if there's not one single person owning something, it's a team owning, everyone needs to agree on how it should be done. And that's a communication issue, a collaboration issue as well. Reduce friction. That means as often as you can, if you can have something self-service, make it happen. Self-service could be a Git repository where if you want a new group, you go get a group, you add it into the YAML, you submit the pull request, and when the person responsible for this repository, they can just merge it, and that will just happen. And I mentioned this because that's what we did during the DSE workshop. Self-organize. When someone tells you what to do, you don't know what's the vision behind it. The vision should be clear. The tasks should be defined across the team, and then the team should pool the work to say, well, we're going to work on this and this and that. Priorities should come from the business, and that should be your focus. So self-organizing doesn't mean do what you want. That means doing the right thing. And doing the right thing means you need to understand what is right for your organization and at the time of the task. And continuous improvement, don't try to do it right from the first time. Just try to always improve what you have. Focus on outcomes. If you want to drive the impact, it's not about what you think is right, it's what really will provide value to the business. So be business driven. Small batches, it's easier to make many, many little improvements than one big project that takes 6 months. Why? It's because you will have shifting priorities. So don't try to go underground for too long because then you will lose track of what's happening in the business. Do small things often. Plan. And then that means if you plan small items, if there's a shifting priority, you can obviously not getting an interruption, but you can say, well, okay, we'll do that just at the next iteration. It doesn't have to be right now, probably. And if it's something that needs to be like a fire that you really need to extinguish, you should have the time to do it. You should plan for this kind of scenario to happen. But everything else, you have blocks of time where like a sprint, and then you just work on that sprint, and then nothing should interrupt that sprint. If something else needs to be done, it should be done the next one. And then it's about continuous learning. You're learning that, okay, have we made an impact? So for that, you need to have the feedback as well. And in the end, you're managing product, not projects. There's no end date for something which is in production. If you have a bit of code which is running, it's not because the project of delivering this code and this feature is finished that you're finished with it. It's running, it's a product. You need to maintain the life cycle of the product. And if you have many products within one team, maybe you have a challenge there. So you need to understand everything you're doing as one big product. Maybe it's a platform. So if you put this into perspective, you can put them into a maturity model in some ways. Basically, you can have different levels of maturity, and you will see that some characteristics of your organization will tell you roughly where you are. And if we start with the ad hoc, when you have no automation, lots of incidents, lots of interrupts as well, everything is ad hoc. And that's just not to write chaos because, it's not politically correct when you show that to companies, but that's pretty much what it is. And one important point is when you have the failure to leverage previous efforts. When you can't, every time you try to add something, you have to start again, because you can't capitalize on existing code. Maybe you don't have modules, and then you need to take again. And say, well, it would be simpler to just rewrite it from scratch. That means you lack standardization and things like that. And then you look at, when you direct it, that means there's someone above you that says, well, you need to do this. You need to do that. they orchestrate the work. That means it's taken away from you to understand the big vision, and they know better, so they will tell you what to do. But sometimes they say, well, there's a process for it, there's a checklist, follow the checklist. And then do this automation, but only in this area. This part is not automated yet. So if you come from a chaos of something where it's really ad hoc, you don't have a choice than select what you're going to automate initially. Then as you progress, you will start, doing code sharing. How do you manage that? How do you start to collaborate on some scripts? Are you going to send them on a file system, or are you going to use Git? And this is where we're going. So the good thing is 5-10 years ago, I would say 90% during these events like PowerShell conferences, 5-10 years ago, everyone was in the chaos mode. Everyone was reacting, extinguishing fire. I would say now pretty much everyone is more or less between ad hoc and directed. But that took 5 to 10 years ago. So how long is it going to take for all of us to go and progress into cooperative and improving and collaborative states? And we'll see what needs to be done to get there. Who's using Git for managing their code at the moment in their company? See, there's about, I would say, 70% of the people here. A few years ago, there would be maybe 10%. So we are already progressing, but in my opinion, it's a bit too slow, and that's why I wanted to go back here. So when you go at cooperative and improving and collaborative pace, if you like, you have lots of elements that you can do and look into. And all of these little elements help you finding, what I need to improve. And if you look at all of these items, some of them have different icons. Some of them are technology, some of them are processes, and others are the culture. And the culture is also important, but sometimes the hardest to get right. And if you remember what Jeffrey Snover said, it's what you do that makes the culture. Don't try to say that you're doing something different. It's about what you do. And when you try to go into that path of progress, you will find that there's some very foundations really important, and Git and source control management, these are the key elements into what you need to get right, to understand, to be efficient, and that will enable a lot of scenarios for you. So, if we go back to the question, how to produce more value? We still have to go a little bit more, what's the process that we use to produce value, or what the process should be at least. So there's this DevOps lifecycle loop, and then you want to streamline your value creation process. And there's more than one step to it. There's the part where you're gonna create the feature, and you will operate the feature. And hopefully when you get that right, you will deliver the value. But the value is created only when what you've developed has been used. Otherwise, it's just potential value, but that doesn't mean it's used. So you spend time, you cost money, but then there's no return on investment. So if we look, so what this process is meant to be doing is build a working culture that breaks down the traditional silos within IT and its users throughout the lifecycle. And when we say users, that means your customers. It could be another team that uses your platform or your automation. Maybe it's help desk trying to get their job done, so they give a better experience to the end users. And that starts with planning, and that might be the hardest part to get right, because it doesn't necessarily, it's not only you, it's how different teams collaborate together, who's giving you the work. If someone orders you to do something, maybe you don't have a word in there. So that's the work management. Very hard to get right. There's obviously agile methodologies, and I recommend everyone to learn about those. They're a toolbox. Scrum is a big toolbox, and there's many different issues, and there's the Scrum for Dummies, which is a good book to get started, for instance, where they will tell you, you can do this, do that when this situation happens. It doesn't mean you need to implement it by the book. That means if you have a challenge, find why, and then try to improve this. And do it as a team, not just alone. And then the code, we know that, it's tracking changes, writing code, version artifacts, formatting standards. That's the usual stuff, and we will get to that later. And the build is when you have your source code, your dependencies. What do you do with this? How do you compile that? How can you make something which is easier to manage, the source code to manage, and then to consume it? And then the test, how do you build trust? Trust, very important. You do something, if you don't trust it, someone will bypass it, will not use it, and then the value will not be created. So build trust for you and for the people using your product. Improve code and functionality, and try to continuously integrate with other parts when you have a system that gets a bit complex, and always test and integrate your system. Sorry, I went back. Manage your release. And then in the PowerShell space, there's the release and there's the publish. You want to make something that you've created available somewhere. We will get a bit more details in that. You want to stamp the artifact, this is something we can use, and then you make it available, let's say in the PowerShell gallery, to say, well, now you can use it. If no one downloads it, again, value is not created, only potential value. So that's not the end of the job. And this is where we get to the ops part of the lifecycle loop. And then the deployment is something I would say slightly separate. You have made it available. It's not necessarily in use yet. That might be a different responsibility because you have more business logic. It's not because there's a new software that you will install it on everyone's computer. So there's a deployment process that needs to go with it. And then you see there's a traffic light because you want to be able to say, now you can go, and then you can go to the next ring, or no, you stop because it's too risky, you wait, or maybe there's an issue, we need to fix it before we go again. Operate, you need to continuously manage what's already there. You need to adapt to demand, react if there's an issue, and that means probably go back to the cycle and prepare the planning phase as well for the next iteration. And then you need to monitor, make sure that you have the metrics, you have the visibility, and you learn from what's running, so then you can prepare the next phase, and then you continue again the next loop, and then again and again. So each team's continuous process, because each team will have this process and implement it. And it's like in an assembly line when you have different stations. They build something, you build value in your team, and then it's used by another team. They use the laptop that you prepare, the patching, the system, the infrastructure, and that's the same thing. And coding is a tiny, whiny part of this. Okay, so if you're a PowerShell developer or if you just do PowerShell, think it's just part of the problem. Think about it as a whole, and if the code is not used, no value is added. Remember this, very, very important. So if you try to have a very good idea that's going to take some time, but then you work on this for 6 months, you cost money for 6 months without any return on investment. And that's usually where in your head it's great, in your boss's head is like, no. And that's sometimes where the communication issue is the challenge. So back to this. We have team C, and then we want to contribute something. We do some PowerShell. So the value chain is actually, to put that in production, the value chain has different processes that does, and that together you provide value to your end customer. So let's go back again to that question. How to produce more value? It's easy. Because we write software, ship better software faster. And you can say, well, I'm not a coder, I'm not a programmer. But if you're here and you write PowerShell or you use PowerShell, I'm pretty sure this is the key element for you. You have to write and to ship, important, to ship better software faster. And you can say it's obvious, but it's not obvious how to implement it. And what we've seen now, we know where the maturity is, and that's the steps that will help to deliver more value quickly, and then with more stability, and improving with the metrics that you've seen. So how do we get that? Well, crafting business value, coding is a fraction of the job, remember this. You can add business value by reducing the work, automation, lean, very important. If you don't want to do something 3 times, obviously improve the quality. Sometimes people say, well, I've done it, and then another ticket is created because, there's this issue, and then you have to fix it. That's rework. You think it's done, on paper it's done, the project is finished, but then you have 25 tickets and issues, which is from this work. So you think the project is finished, and then it's support. No, that's one product that you still need to manage and fix the bugs. That should be part of the same product, not just a project that finished. And consolidated business value, you need to have this product mindset. So again, the key element, ship better software faster. So we've seen so far contribute to customer value, built along the value chain. Each team is a link. And that's very important because you have more than one customer. But you need to understand for priorities where your customers are and how important they are. If your CEO of your company asks you for something, probably it's important. So that means in the value chain, they're quite important. So find it and ask, and that's the kind of documentation that is good to have. So no, Ben would say, but Git, we talked about Git, that was the talk. So what's in a PowerShell module? In a PowerShell module, you have functions, public and private functions, you have classes, enum, tab data, and then you put everything together in a PSM1, and then you have your module manifest, and then you have maybe some type informations. You may have some dependencies, a DLL, some files that you need to have. And then you put everything into a folder, that's your module, but if you want someone else to be able to use it, you will publish that module with the publish module command. And then what's happening is basically it takes an spec, it generates an spec, it zips that into a new peg, and then publish that into your gallery. All right. What's important is if you want to improve, so build software faster, you have the lead time and the cycle time. The lead time is from the idea, I have an idea, I would like to create this, until it's deployed and used in production. The problem is having an idea usually doesn't take that much time. Having time to work on that idea is already one of the limiting factors. And then sometimes you don't have the choice, especially if you just the developer, someone is telling you what to do. You don't have a choice on which task you should be working on and things like that. So the only thing that you can really focus on is improving the cycle time. So from the moment you start working on the task until it's deployed into production. So we need to optimize the cycle time. How to do that? We need to focus on the element of this process which allows us to create and deliver this value. So from the task, we start coding, and then this artifact, which is the module, is built, and then it's deployed to the target. For that, a good thing as well is avoiding issue later in the game. So the quicker you have some feedback that you're doing something wrong, the better. Because if you have to wait that the build runs or someone uses and then it's tested in production before it fails, it will take you a long time to troubleshoot this, to find the error, create a fix, and then push a new version. So the idea is the longer the feedback is, the more impact, and it's going to be too late. So you need to have quick feedback. So when you build this pipeline, you need to have very quick feedback that will help you do better software faster. And then that means you need to shift left, which is shorten the feedback loop. If you can bring the security as well more to the left, that means the security people don't have to wait like, you've put that into production, but you used the wrong DLL. And that means you need to rewrite your software with a new DLL, and then maybe it will be more secure. Or you should have told me that at the beginning of the project. You see, shift security left to improve your lead time as well and avoid waste. Am I missing anything there?
Perfectly.
So what does it look like? A real pipeline. Can you show us?
Let's see. So, by the way, who of you is developing modules, PowerShell modules? Okay. Who has a fully automated deployment mechanism so the module gets published somewhere, externally or internally?
4.
Yeah, a lot
5.
less. So how do you deploy the module in your internal gallery? Do you have an internal gallery at all? Or do you just copy the module to some file shares?
Internal gallery?
Not many.
Only a few.
Internal gallery that is a file.
Yeah, it does.
Okay.
Do you know that you can do publish module on a file, on a folder, and then that will do the thing that you've seen when it packs your module, and then it does just drop it the new PKG on that file share, and that's a very good way to test your module building process.
So for those of you who have been in the code signing session, you might have seen this little test module already, which is that one here, just a sample module that I reuse for every conference. And here we have the typical pipeline, which is 3 stages. The first stage, of course, is the build and the test. And if everything runs fine, then we are going into deployment in a fully automated way. Shall we
Cool.
go? Right.
What?
So do some changes?
Yeah.
You do them?
No, you do them. No,
I do those changes. Okay, good.
I need to fix my PowerPoint, sorry.
So if we want to do a change to the module, then of course what we do first is creating a branch, right? We skip that here for now, we will do it later. We skip it here just to speed up the process. So I just changed something in the file, like extend the comment, including a typo. Perfect. Okay, so we have our little change here. We edit. I always generate the commit message using GitHub Copilot. Gael hates it. This is why I'm doing it.
You're wrong.
Okay, commit. And we sync the change to our GitHub repository. So in an ideal world, I mean, the goal was write good software quicker and deploy it quicker. In an ideal world, we don't have to do anything to make the software available. And if we go back to the pipeline, then we see it's already triggered, and it will do all the steps that are necessary to get the module available in our PowerShell gallery. So what's the name of the module?
That's not the private one.
That's not the private one.
Which is so that everyone can access and find that we making changes live, which we shouldn't do, but.
Yeah. So here we go. And I've released a module, or a new version yesterday, and in a couple of minutes, the new preview will be available. And the good thing is, it's always a preview. So releasing something to the gallery would be pretty risky if it is a full version, because people are immediately downloading it and using it. But the pipeline that we have is only releasing preview versions. And if we have the necessary feedback and know that the trust has been established in our module, then we use git tag to initiate a full release. And Gael said something about the feedback loop. We want to have feedback as quickly as possible. So before even pushing something to the official repository, to the GitHub repository, first I do a build locally, right? So if my build fails locally and my pester tests are not satisfied, then it doesn't make sense to push the changes. First, I need to fix the bugs, right? So we are failing locally first, very quickly, and then we are moving to the right, as has been shown on the slide.
Keep going.
Good. Have you heard about the sampler project?
Or press, or what are the others? Build pipeline.
Who has
Sorry?
You said mine, so that's all
I know yours.
Who has heard about the PS development framework from Fred Weinmann?
Yes,
Only
one
one?
there.
Okay, so if you build a module, then all you guys are starting from scratch then, without a pattern that already does a lot for you, right? Yeah, that's sad. Okay.
Who's writing module? Okay, there's still half of you. Okay. If you're not, and you're writing some PowerShell script, you should be writing modules. Just saying. Yeah. But we can discuss that later outside.
Okay, so what sampler does for you, it creates a structure that kind of summarizes the best practices and the learnings of the PowerShell community of the last 10 years. So what we have in our structure, and you might recognize this, the file structure here, because a bunch of modules publicly available are implementing this. So one of the features is that we have a fully automated dependency resolution. So our required modules file defines what has to be downloaded in order to make this project working for the build time, not for the runtime later after deploying it, right? We always have a test folder, and the test folder contains our pester tests, which are mandatory. So we have a test that checks if there are tests, right? So if we are missing some very important pieces like the comment-based help, or if in the comment-based help a parameter wasn't described already, then a test fails and then we have to start again. Then we have a separation into public and private functions, right, out of the box. So all the functions are merged into one big module, but only the ones in the public folder will be made available, right? Then we have an output folder, which is always clean. So if we start building the stuff again, then what happens is, see, it was a bit too fast, but one of the first tasks that we have is clean the output folder so that you know what's in output is your last artifact that was built and not some kind of merged stuff over the couple of weeks that you worked on the project. We have automatic linting, which means if we have agreed on a coding standard and we want to make sure that every piece of software is according to the coding standard. And we have that here in VS Code. We have the analyzer settings and we have the project settings. And here, for example, if we have agreed on a coding format, you don't need to argue anymore. Should the open brace be on the same line or on the next line? It doesn't matter anyway, right? But it's important that we have agreed on a standard. Because what I hated the most is when we work on datum, first, because datum is a pretty old module, we didn't agree on a coding standard. So I fixed some issues in datum and then pressed Shift, Alt, F to do the formatting, and the whole thing switched to the new coding guide, coding standard, and therefore Gael didn't see my changes anymore because the whole script was changed, right? So coding guidelines are very important, otherwise the formatting will change too much.
And think about when you have one project, it's okay. Think about, so we use that, and that's been created mostly for the DSC community, which has more than 90 modules. So 90 repositories to manage. If they're not written, if everyone, because we've got many, many contributors, if everyone goes with their own style, it's going to be very tiring when you get a new repository that you need to do a review on, and then, oh, the brackets are all over the place, or the things are all over the place. So it doesn't matter. I don't mind if it's not my coding style, and it wasn't at the beginning. At least it's consistent, which makes it much easier to review, much easier. And then that's why there's like some of the coding style are really old because the DSC community has been there like since 2013. So so it's not necessarily what people do, like the brackets, and maybe not at the same place. But otherwise, it's much easier to review. So as long as you're doing the same thing, even if you have 90 repositories, you're not lost or it's not painful to read.
Yeah. So almost done. One other thing that just jumped into my mind is the changelog. Who is maintaining a changelog in a very consistent way? I always forget it. Therefore, we have a test in Sampler that checks if the changelog has been changed. We can't verify if it contains the right information, but at least we can verify has it been touched, right? And then we automatically, in the release process, move everything from the unreleased section to the section that gets the correct version number, fully automatically. You are just maintaining your unreleased section, and at some point in time, it will be moved. And the last thing is versioning, right? So we don't set the version manually. It is all done by Git version, which is also responsible of having named this as, what is it? Preview 3, right? Without anything, it just iterates based on the, I think, the commit message, or is it
the tags on the commits and the branch it's coming from. It's a whole session, and that's a bit more complex, but you don't have to rely on someone to make the changes and to remember to have a logic. So if you're familiar with the semantic versioning, that's something that you can have it if you have Git version configured automatically, like your repository will manage the versions and everyone will generate the right versions. So it's something that happens on machines or on the build agent, and you don't have to think about changing the version ever again. I haven't changed a version in a file for many, many years now because we're using this.
And here it is, right? Git version, you can also invoke it directly on your machine, and it calculates the next version that's going to be. So the only question left is, who is downloading this demo module, right?
It does nothing.
It does nothing, right? But there are a couple of downloads.
But it's there, and then you can see it's been released a few seconds ago.
Okay.
Good. So now I would like to make a proper change, because what did you do? You actually changed directly to main, right? I don't like this, so I think we should do something different. Where's my mouse? Yeah, I know. Sorry. And then I'll duplicate, and that should pop up. Now.
All good.
Yes. All right. So we'll go back, and it's about Git. So we will do this. I will go into my dev environment, and then I want to take. This is the repository, and I'm lucky I have access. My SSH is configured. You can find the documentation. We're not going to spend too much time in there. And then I want to git clone what's in there. All right, the clone is done. So if I just code, and it's called a weird name, sorry. So now we can find, and I will probably change the color theme to something more light. Sorry for that. Here we go, the good old ISE. And I will make it a bit bigger. All right, so now I have access to the code and everything's in there. And so I just wanted to do something. I want to make a change, but probably I'm not allowed to change that directly in main. So I need to create a branch. It's true that if you're working on GitHub and then you don't have access directly to the repository, you could create a fork. I'm not going to go too much into details, because if you work in a company within a corporate environment, usually you don't have a fork process. You don't fork the whole repository. Sometimes, or most of the time, what I've seen is people just are given access to create branches within that repository. So I will try to do this. So what happens if I could use this? You see, we've got the UI from VS Code that lets us create new branch and all of those things. What happens when you use the GUI and then you don't know what it does?
Things go wrong.
There you go. So I'm not saying you should really learn all the command lines for Git, but sometimes it's easier to use a bit, or to at least look at what command is executed, so then you know what is used, and then you're a bit curious, and then you will learn a bit more Git. The problem with that great GUI is you've got a big blue button, but it changes depending on the context, and then it's got a different name, but sometimes it does something like syncing, but you not necessarily know what syncing means, and it actually does several operations. So if you start looking at the doc with the Git commands and you do that online, sometimes you learn a few more tricks. But sometimes, most of the time when I do conflict resolution or things like that, I'll go back to the GUI because it's just much easier. All right, so I've got this, and I can see all of Raimund's commits that he did before. And let's say I want to have some information about what he changed, and I can go here. You will see that Raimund Andree 12 minutes ago, and that's the commit message. So I have information about what he just did. So when you work and when you collaborate, and this is using GitLens, which is one extension of VS Code, in a second, you have information, all the metadata and everything that happens. Justin, what have I missed?
VS Code now has native support for this Git claim, but it's opt-in, but it's built in VS Code.
Oh yeah, so you don't ever need the extension anymore. So that's good to know. Sorry, but yeah, you can go. And I'm probably not up to date. I just realized that earlier. Yeah. So you can find information about who did what. So when you're collaborating on some code, then it's much quicker to go and get access to the information. So if you're not using Git yet, just this feature alone will save you so much time just to track down the changes and who did what and when. And if they write their commit code properly, maybe you will know why. And yes. So this is not really good. So what I'm going to do is I've changed something, but I'm still on main, right? So I probably should not commit on main. So I will just.
Only I'm allowed to commit on main.
Yes, so I'm not allowed. You see, he just gave me permission 5 minutes ago. I've never seen this repository before, so we're just doing it live. And if you have questions, feel free to raise your hand and tell us. And I can't see you, so just in case, because you're just behind the lectern. All right, so I just want to create a branch, and then I have this naming convention, but that's me, but well, the DSC community, and then based on the name of the branch, it may be able to change the version that is created. This is advanced configuration for Git version. I'm not going to specify, but when I do F, it's for a feature. If I do fix, it's for a patch. And then if I, in my commit message, write something like breaking or breaking change, that means it will change the major version of the module next time we release it. So I'll do a quick fix. Raimund is wrong. There we go. And then, yes?
Oh, no, it's good.
Okay, sorry.
Questions on that. What was it? Yes, why use git checkout instead of git branch and git branch? And with git checkout, I've noticed you made the change first, then created the new branch.
So I could have created it. So when you do, oh yeah, repeating the question. So why did I do git checkout -b and not a git branch, or creating the new branch, then checking out the branch? Honestly, I'm just using to do that, but I'm just used to it. But basically here, in one command, I create the branch that doesn't exist yet, and then I check out that branch in one command instead of doing two.
So no longer
It's wherever I am. So it just creates it not from main, from wherever I am. And I was in main, so at the point in time, it created a branch from there, and then it put me into that branch. And now I can add the changes that I want, and the GUI is great for this, because if I look over there on the right, I can see what has changed. And that does a diff of the file that has changed. And I can say, well, I want to add it there, which is git add name of the file. So now you can see it's in the stage change. Actually, I prefer, yes, it's the tree view. There we go, you can see it's coming from source. It's a bit easier to see. And then I can say, well, fixing Raimund's wrong change. All right. And then I can do a commit.
Maybe to clarify it, when you're saving locally, you're going to commit it to a branch. It's just a file that's saved.
Okay.
And so what he's doing now is in his branch, he switched to his branch, and he'll commit it to that.
Yes. And I'm pushing this. So I go git push. Oh, it doesn't exist, blah, blah, blah. So I just need to create this branch on my remote. We will explain a bit clearer with visualization what's happening when we make those changes. I'll just show you directly into the terminal what's happening, what commands are running, and then we will go back and then see what happens. So if I git push, not main, but the name of my branch, which is fix, Ray, and I regret doing a long name here, Raimund, you know what, I can't type. So git branch just to see, and that's the one I want. And then I'll do again git push u, origin, and then I copy this. So now it's taking my changes, it pushes them to the remote repository, which is on GitHub for this case, and then you can see that I can go, what did I do? No. Oh, that was to create, sorry, I didn't see what I was clicking. That was to create automatically from VS Code, but I don't want to do that. I want to go on the website in this case. And then that allows me to create the pull request right away. If we switch to Raimund in a second, he will be able to see that the branch has been created. So let's go to Raimund's computer. If you go, oh, you're not on the right folder, there we go. Can you look in the branches? You can see now there's 3 branches, and they should be the one that I just pushed. And I will create the pull request. So if I switch there quickly, I create pull request. The pull request is, like its name says, this is something integrated to GitHub, but everyone needs to remember that before we had GitHub, the idea was just someone say, hey, I've made a change in the clone that I have, in the fork that I have. Can you go and take it and merge it into your repository? So that's why it's a pull request. You ask for someone to pull the changes. Think about before GitHub made this easy, or the other ones, you know, Bitbucket, GitLab, and all of those. Before it was more of a manual process. So now that we've got this, Raimund will be able to see this.
Yeah, let's go to pull requests. Do you recognize something here? I mean, of course, the pull request is there, but there is also this orange button next to it. And that means I'm not trusting Gael, never.
You're right.
So we want to see first if the pull request is valid, if it builds, right? So the same tests that we did previously locally are now running within the pipeline. So, do they? Yeah, view details. Here we go, and the build is currently running. It will not publish, it will only build and test, and then I get a notification that everything is fine. And not before then, I will take a look at the pull request.
Because there's no point for him to actually try to see if it's good work that I've done until he validates that it passes all the tests. So it saves him time, because if I get it wrong, and I usually do, it's going to take me many more commits before the thing works and pass all the tests. So at least now, when he will have a green light and he will look at this, it was that, well, there's a good chance the change is correct. So he doesn't waste time. And then for me as well, it's about the feedback. You can see that I didn't test on my machine, I didn't run the build. So I've skipped that test, but if it fails, that would be wrong because it's wasting my time because now I need to wait for the few minutes it will take to build this simple project, right? So that's why the feedback loop is important. And in most cases, if you don't change it, it's just a command, so we know it's going to work. But as soon as you start doing things more complex, go and test on your machine. Make sure you develop something which you can test so that the feedback loop is quicker. And that usually is hard to achieve for some projects, but the more you test, the better it is. And who's using Tester? Oh, more people than I thought, but there's, I would say maybe 40%. That's really something that if you start to learn it and then you get into the habit of, I would say probably not test everything, but test a little bit and then increase. I don't say test everything because it takes a lot of time. And if you change all the time, it's hard to see the value at the beginning. So maybe this is not where you constrain it. But as soon as you find that you need to have more quality because there's a project you spend a lot of time working on, you will see that the little test you have you will be not enough, but it would be a great start. And then you will start really writing all the tests because you know that if someone else changes something, you will trust more that probably it's not going to break.
And I would like to add, since a year, I've discovered that Copilot is very good in writing pester tests, at least to give you a structure and the initial start, right? And then you can make it more precise and more oriented to your business, but it is amazing how quickly it analyzes your software and comes up with proposals that are really valid and good. Justin.
Just as an add to that, especially with the Claude Sonnet 3.7 model over the OpenAI one, at least in my experience.
Yeah, Claude, and what I'm using is Klein. Klein is an extension that is not only writing the tests, it's also invoking the tests, analyzing the feedback, and then changing your code depending on the feedback or the tests. So this was kind of magic. Yeah.
That calls for another session.
It does.
So where are we at?
Tests are still running.
Okay, you see, that's the delay in feedback. But hopefully my change was correct, so we will be able to see what's happening. So we need, okay, so we've created this, and then I will show you actually what I see. So it's still running, and then I can see that the check hasn't passed yet. But I can see as well there's no conflict in the branch. Have you sometimes issues where you make a change, someone else in your company make a change, and then you don't know why there's a conflict in there, and it takes you a lot of time to find out? Yes, that's painful, right? And usually it's because when you started working on your branch or on the changes, something happened on the main branch, and then you try to merge things together, but you touch the same file. And then the problem is sometimes, well, you try to get every changes together, and then the more work you do, it just adds, and there's more commits, and then you can see twice the same commit name, although the ID is different, and you don't know what happens. And that happens a lot of times. So we will try to explain this a little bit, what's happening in those cases.
Code coverage, but it's done. Yeah, it's done.
There we go. So all check passed. That means someone should be able to merge the pull request. But should I merge the pull request? Probably should do a code review first.
Yeah, let's do that.
Okay, so you switch to your computer and then you do a code review.
We go on files changed. Well, that looks okay.
That looks okay?
Okay, but only okay. Not nice, it's okay. Good.
Okay.
That's
So do you know why it's a very good practice to have code review? Not just for the quality. What's the main advantage to do code review within your team?
yeah.
Yes, it's about sharing the information. So then you're not the only one, and then if you hit by a bus or on holidays or whatever, win the lottery. Oh, that's the best one.
That's positive.
I will steal that one. So when you win the lottery, at least someone's like say, you win the lottery, and then we don't know what you did. No, everyone is aware. So here we go. So now, so you reviewed it, you approved it, so you can merge.
Yeah, and another question is,
Oh, there's different ways to merge.
yeah,
Yes.
but I think this will be covered later in the slides, right?
Kind of. We will get back to this when we see about the commits and the commit IDs, because we will understand a bit more what's happening.
So let's follow the default way.
I just wanted to say that usually when I do this, I approve. You know what's happening. When we run this, it will be merged to main, which will trigger a build, and then create the new module and publish it again to the PowerShell gallery, right? So I usually let the person that created the pull request do the merge if they have permissions to do so, because at least they will know and they will follow up the build process, and they will see that it's been published, and then they can do an extra test or make sure they send the email to say, well, we've done this and this is done, right? This is published and it's available. So it goes back to, if no one uses it, then the value is not created yet. So if you let people if you let people do it, then they will follow up with the process, and then they can ensure that everyone is aware and everything's happening. So I will go and I will squash and merge. No, I will rebase and merge, and then we will explain later what it does. So what's happening now? It should be. I actually merged it. So if
You did?
yes. And then if you look at the build, it should be triggered.
Of course. Here it is.
So you can see, click on it, and then we will go back. And that's
there it
the
is.
build, and then you see, it knows that I've triggered the build with the merge that I created. And then it will go again. So what we're gonna do, we're gonna go back to the slides, and then we will explain, no, I don't want this. I will do it 1 second. That's why I wanted to do this. And it's extend. There we go. And no, that should be.
So is it running the same test that it ran when you committed the pull?
Yes, so the same tests are running all the time. So locally, when creating the pull request, but then it's omitting the deployment step, and when merging into main again.
Pull.
Yes, yes. So the difference between merging in main and committing something to a branch is that we are just skipping the deployment step. Okay. That's the only difference. But the build process is always the same.
So what happened there? Locally, can you see? Yes.
All good.
What happened there? Locally, I started by cloning the repository, so then I had the source code that he wrote, and that was on GitHub, and then I cloned it locally, so then I could start my work. I made a change to the file, and then I made sure maybe the linting was correct, so the formatting and everything was correct. I should have, but I didn't. But I should have built it locally to make sure the build works. And that is the first validation step. Sometimes in my build, I will be informed that a dependency is missing, or there's a parsing error in PowerShell, so the module will never load, right? And we stamp it with a version. This is what Git version does. We've shown you what happened, and basically what happens under the hood when you run the build. It will go in the PSD1 and then change the value of the module version. And then we run the test, and that's the other validation that we have, and we should have had if I run it properly. And then I create the commit, I make sure this is okay, put that into my branch, and I push that to my branch. And my branch is pushed to the fork or the branch. It's different models, but if you're in a corporate environment, most likely if you have write permission, it will be a branch. And then the commit is pushed over there. What happened there? I created a pull request, and creating the pull request started the CI job. The CI job did the same thing as we have done in the machine. It did a git checkout, took the code locally onto the build agent, run the build, stamp with the version, run the test, and then it says, well, that looks okay to me. And then it tells the PR, as you've seen in the GUI, there's the checks, the check passed. The next step would be the review. The review is okay, so now we can take the code that was on the branch and then merge it to main. So recreate the merge. And this process, having the new commits on the main branch, triggers a new job. Again, it's a new CI job in Azure Pipelines. And this starts the checkout process again, the build process again, so it's a fresh thing that you have, and stamp the version, test it, but in this case, and we will see in Raimund's screens in a minute, started to publish the artifacts created directly into the PowerShell gallery. So if we switch to Raimund's computer, we can see, if you show the one you did before without publishing.
That one?
Yes, this one. And then you can show the artifacts maybe in,
Sure.
over there. These are the artifacts on the pipeline. So we know they exist. There's quite a few things. There's the test results, the code coverage. That's the kind of things we can have. And then you have the new peg at the very bottom. So you have the file, which is the zip file. I would say a fancy zip file with a new spec and all your module within that. Do you know what a new PKG is, new peg? No? Yes, some of you? Maybe you can download it and then you unzip it. It's a fancy zip file, but it's good to know what happens underneath when you write a PowerShell module.
Quick question.
Yes?
All right. In that full process you just showed us, if you did it like you're supposed to, yes, how is that local build and test run? And in the case of PowerShell, I understand. I think of it as the build step as, the test that you're running. But in this scenario, how are you doing that locally?
Oops, sorry.
What kind of strange folder is that?
And as an example, this is the same thing. This is the same thing Raimund ran earlier. He ran the build. I'm just adding a few parameters.
You still see the slides.
Oh, yeah, sorry. Let me just do it. Damn it. It's okay. It's running. Duplicate. So I just needed my notes in my slide. That's why I changed. Can you see now?
So you just run.
I just run the build.
Build script. Okay.
Yeah, everything that's running in the agent is a build script. That's why we use sampler. So basically, we're showing you that with Azure DevOps and GitHub, but we do that with GitLab. We do that with any system. Bitbucket, I've used TeamCity. I've used many of those. Same principle. Most of it is just PowerShell scripts running anyway. So we can run it in PowerShell 7 and things like that. So it's something that anyone can use. And that's why Sampler, the module we discussed, but there's others, there's Press and the PowerShell framework as well. All of those things are meant usually to be running anywhere. So whether it's a build agent, whether it's your development box, you can just run that.
And that's very important because I've seen a couple of projects at customers that have the complexity of the build pipeline, not in PowerShell, but rather as a bunch of steps in the YAML, Azure DevOps, or in the GitHub Actions pipeline. And debugging these steps is very, very complicated. And here we have a PowerShell script that we can set breakpoints and know if it works locally, then it will also work in the pipeline and vice versa. So the debugging aspect here is also quite important.
Just to clarify, when we go to the output, so if you see yeah, if you see my screen there, the output is where we've actually compiled this module, and then you will be able to see the module that we used. And this is the thing that's been packed into a new peg. So now if we look at what's in the new peg, this is Raimund's computer, and then you will be able to see that it's just your PSM1, PSD1 file. You have the new spec as well, right? And the only thing it did, like it ends by .newpkg, but that's just a zip file. So you just unzip it, and then you have access to those. Yes, question?
So if in the build, all it is a PowerShell script, is there still like environment concepts like a dev, a test, a prod? With the other builds I've seen, there's usually like a YAML file or something, and it describes this is what happens when you commit code under a dev file.
So I would say no, and it's so the question is there like different environments, like a dev environment or prod or information about the environment? I would say in general that's probably not a good idea to have it there.
I'll say congratulations, you just learned the difference between CI and CD.
Sorry, what?
You just learned the difference between CI and CD.
Yeah, and so what we have is definitions. I would say yes, there's some build definitions, but that's not environment specific. It's not about doing this in dev and doing things in other environment. What we want to do is build an artifact, and then the deployment is something separate, which is we want to deploy something somewhere, but that's based on business reasons.
Because I mean, how could you trust your software if you have a different build strategy, a different artifact in dev than you have later in prod, right? We want to have definitely the same artifact propagating through the rings, so we can exactly be trusting that artifact and know that it's the same.
I tested prod. I was just asking.
Yeah, no worries. All right. What do we do now? Okay.
I think.
Yeah. Is it me? Is it
No,
you?
that's me.
There we go. All right. So this is the process we've seen. So far, that's clear. Who's using a process like this? Okay, 3, 4, 5. Okay, that's the same as earlier. Okay. So we've done the demo about doing this together, and it could be worse. I don't really have much. We don't have that much time left, so I want to go and explain what's happening. So Git is multiverse management. We've got the MCU that really helped us understand the multiverse on the different timelines. And that's the most recent teaching about Git that we had on television and on big screens. Git is not just about the version control, right? It's a collaboration tool, it's distributed, and then it's to manage change events. But it manages timelines and it manages multiverse. What do I mean by that? Do you remember probably the first Git lesson that you've seen on television? Do you remember that?
Dr. Who?
No. Back to the Future.
Long time
Look,
ago.
this is timelines, right? This is what Git is all about. You're managing timelines. What is he doing now? There's a branch, right? Let me just do something, because there's a quote. Oh, no. Oh, yeah, okay, that's fine. Let me just duplicate so I have my notes. So basically, he says during the, I think Doc says at some point, which is an important quote on this one. Okay, so he says, alternate to you, me, but reality to everyone else. And that's an important quote, because that's what happens when you have different forks. You have different environments, which is universe. They're in parallel, but until you sync them together, you have different reality, and people will see different things. And why is it not working the way I want? Because I can't do it. There we go. And I want to extend. Thank you. And I'll go back to the slides, because I've got notes and I'm too tired. There we go. So you can see. So alternate to you, me, but reality to everyone else. So if we think about, the timeline, we add events. So we create commits, which is a change event. We're changing one file. We add one line, we remove one. Okay, that's an event. And we add those onto the timeline. Okay, that's easy. That's when you change it on main. When Raimund went straight on push to main, that means you change this on main. So now, what I want is, create a new branch so I can make my change. So it's a new reality for me. So I create that new branch, I create the branch in the timeline, and then I will make my changes into the timeline. I add the file, and then I commit the file with a message, and then that creates my new events into this timeline. In the meantime, someone, maybe Raimund, changed something on the main branch. And that's important because now I can't see them on my branch, that's my reality, but they exist on the main branch because of him. The problem is if we want to put that together, and that's the default configuration with Git, it will create a merge commit. It will take one branch, it will take the other branch, it will say, well, I guess we're gonna do this now. And that creates a merge commit. The problem is that is like creating a new reality, which is merged from the two. So it's very hard to keep track of what's going on because there's no continuity. It's just one plus another, merged together through a commit. And then it's hard after for people to keep track. And imagine you pushing that, and that's a new reality, but someone else already branched out before that, and now they have nothing like what's on the repository. So instead of doing this, well, the problem with this is there's merge commits. When you do a merge commit in almost any software, whether it's GitHub, Bitbucket, all of those, you will see like an M or something that says that's a merge commit. And when you're not really mature or you're not really used to Git, this will screw your team completely because the more they will try to fix, the more there will be merge commits, the commit's gonna have different IDs, and then you will see a lot of things, and people will be lost. So if there's one thing you should avoid is merge commit. They're bad. They're bad. If you're used to it, and people who've been using Git for 30 years, maybe using Git flow, they will say, oh, no, that's not true. I agree. If you know what you're doing, it can be useful, and there's very good scenarios to do that. It's probably not your scenario. If you have something that you can just, fix forward, do this. So in this case, we go back. There's some changes on the main branch that I don't have on my branch. So on the main branch, which is the trunk of the repository, there's 2 commits that I don't have locally. I've made my own commits. If I do a git pull, and that's the default configuration with Git, it will take the 2 commits I'm missing, and it will add them to my branch. So it will fetch, git fetch from the branch, and do git merge. That's what the pull does by default configuration. Problem is, look at the timeline now. Everything is like, oh yeah, but the order is not kept. So if I try to push that, it's not going to be pretty because then the order that I will push is not the same, so the commits and the history is different. So don't pull without rebase. Why? It's because rebasing will change how this looks like, and I will explain this with the next slides. And there's a very important configuration that I recommend everyone to use when you do something, when you use Git, especially at the beginning, and you need to make sure everyone in your team does that. That will save you so much pain, is to make sure every time you do a pull, automatically it will do a rebase. So that when people try to get some information, if there's conflict, it will tell you at that time, and then it will do what we're gonna discover right now. So when you do a rebase, or if you do manually without this configuration, you do git pull rebase, it will do something slightly different. You see that I have 2 commits, but Git knows I'm missing 2 commits from the main branch. So it's gonna put my commits on the side, and then it will take the 2 commits I'm missing and bring them into my branch, and then it will replay my commits after on my branch. If you look now, between the main branch and my branch, we have the same history. And then I just add 2 events after that. I'll let you take a picture, but I will share the slides anyway. And then you can do the git pull -- rebase, or if you have configured it, the commands I showed you just before, then any git pull now will use this approach. And that will avoid many, many issues. Why is it cycling back? Oh, yes. So we've seen the principle with the Git pull, and this is when you manage on your local machine. Maybe I had... okay, no, we already did some stuff on, I think we have 9 minutes left. Am I correct? Okay. So let's enter the multiverse. Why do I say there's the multiverse? Is because you have your local copy, and then you have the remote, the origin. That's the central copy. But you can have more than one central copy. You can have the one that, if it's a corporate environment, the one that we have in the company, and then we are shared, and then we have different access. So I'm only a contributor, is the administrator, but it's the same repository, and I have write access pretty much everywhere but main, because main is protected. You don't want to change main with a push. You want to make sure main is only changed through a pull request. So you add a gate to make sure the quality is correct, the build is running, we validate with a code review, and then we can change it. So that's what we have. We had main on GitHub. And what's happening is we want to have a clone. So we have the local copy. So we take everything, and then we did git clone the name of my thing, right? I created my branch. Again, the same command with checkout-b. So I create the branch, and I just go on this checkout straight away. So I go from local, and then I just, from wherever the point in time I am, I will branch it from there. If there's more commit happening on my local main, they won't be affected on my branch. So be careful if you keep jumping between your own branches. Sometimes that's also some kind of issue. So now that I've got this, let's say I make some changes locally. I have 2 more commits on my local branch, which is exactly what I want. And then I say, well, no, I want to push this branch to GitHub, which is what I did earlier, so that Raimund could see my changes on my branch before I created my pull request. But in the meantime, the main branch on GitHub has been updated. So you see that locally on my main, I don't have it. If I go back on my main and then I fetch the information, then I will update my main. But I don't necessarily need to do that. I can directly from my local machine do I forgot, yes, I can rebase, and then I say I don't rebase with what I have locally. I want to rebase what's on my origin, so on GitHub, on the main branch. Technically, you could do that with any other branch, but in this case, we always take main, right? So we can go and rebase this from what's on this other repository, okay, on GitHub. Again, the same process happens as we've seen. It puts these 2 commits aside. It will pull the missing commits. And you see it changes color for my commits. Why? Because it's not exactly the same commits that we had before. They will have a new ID because they will have a new timestamp. Okay, so they're different commits. Commits are, there's a grid if you want, so they are changing because we changed the order. And then they replay those commits so that it will be the same change. They will just have a different checksum if you want, and they will be slightly different. And now, what do I want to do? This is on my, so my local branch, Gael relativity is, okay, this is the thing I want to push over there. So what do I do? PR? Should I do a PR from my local machine to the remote? No, the PR is only from the remote, so when it's already on GitHub. So I need to push what I have locally. I need to push that onto the server. So what do? Well, I try to do a git push, and it tells me, I'm not allowed. Because with Git, when you push like this, you're not allowed to change the history. If you look at Gael's relativity on my local machine and the one up there, it's got a different history. The events are different. The sequence of events is different. So it will tell me, no, you can't. But I know I'm right. I don't care what's on my branch over there. So I can be mean and I go git push force. And what's happening? It will just replace what's in there on only what's missing because it's the same history. So now if it was merged, you can see it's one straight line with the dots happening in sequence. Okay, now that I've pushed the 2 commits I really wanted to do, that I've done myself, I can create my pull request. Okay? Magic. Easy peasy, right? No, it's not. But this is the workflow that once you get this simple and you've seen all the commands, and I will share the slides, you can reproduce that, and that will reduce many, many problems if you do it right. If you configure it with pull rebase and you do that, there's also some protection rules that you need to have on the remote repository. It will save you so much time and so much headache, especially when you collaborate and you're more than one working on it. So the git push is a bit dangerous. So here, if I do git push, but actually the remote branch, let's go back here. If Raimund changed something on my Gael's relativity branch, and I do a git push force, it will remove his change and we will lose it. So instead of doing this, if we do git push force with Liz, it will tell me, oh, but you're trying to push something, but you're missing this commit from Raimund, and it will fail with a message that tells you, you probably don't want to do that. This happens very rarely, because usually when you work on a branch, I would go, so if we were together and then we work on this, he would go on my fork maybe, and then he would help me contribute like with a pull request to the fork and not to main in between. So to me, that never happens when we collaborate, especially when we do that open source on GitHub, because in the workflow, that happens rarely. But if you're working on the same feature together on the remote, then that could happen, so use force with Liz. It's less destructive and it's less risky to do it. So I think we'll go to the conclusion because yes, we only have 3 minutes left. Business value is the goal, remember that. That's the most important things to take away from this. Git is for collaboration. You know, version control, so VCS, version control system, or SCM, source control management are byproducts in some ways. The goal is to collaborate, to co-create. Keep your workflow simple. This is a workflow that works, and that's what we use mostly on GitHub. Obviously, it's hard to, in one session, to get everything, but if you do that, that sets you up for success with you and your team. We haven't had time to go too much into trunk-based development, but the idea is you have this main branch, which is always the truth. You don't have different branches that you keep. You have this feature branch that, you know, Gael's relativity that you've seen. As soon as I'm finished and I push it, I will destroy this branch locally on remote, and we will start again from the point in time that we have in main. Okay?
He always tried me to convince that trunk-based development is easier, so I was more into Git flow, having a master and a dev branch, and finally it turns out that this is way too complicated for most of the project, so this is definitely a better way.
Don't be like Raimund, trust me. Finally I managed, but yeah. And then there's something I just want to say and not spend too much time. Don't manage deployment based on your branches. Don't have many branches. One is dev, one is prod, because if you want to promote things, that means if you have the 2 branches, they will have to go through everything. And then if something wrong in production, and you want to make the change in production, and it's not in the other one, then you will have to break all your branches, remove the branch, rename from master. It will give you headache. What's important is from main, you create the artifact, and then what you manage in the deployment step is where you put this artifact. I think I ran out of time. We ran out of time. We have 1 minute. We can take a few questions, but obviously if you want, you can grab us. Is there any question about those?
I did want to ask, when should you squash commits and when should you not squash?
He asked me the same question. I would say it kind of depends. You want to squash commits when really, really you have a dirty commit history and you don't want to clean it up on your machine and then do a git push first and something like that.
I mostly do have a very unclean commit history because of testing and testing in the pipeline, and then you have a lot of WIPs, work in progress commits, and they shouldn't be visible in the history, in my opinion.
I prefer to rebase all the time. Why? Because then it keeps the history, and then there's always a reason why you change your code. And but it's true that with Raimund we tend to squash. But otherwise, there's always a reason. There's always a reason why you want to keep. You made some changes, but sometimes it puts too much noise, and that's why you want to squash commits. What's important is never create a merge commit, and never rewrite history, at least on the main branch, right? Am I missing something, Justin?
I don't have enough hours in the day to go through it.
Yes, yes, but like it's yes. The gist is that you can do squash commits, and it's good to. So what the squash commit does is it takes all the commits you have in your branch, and then before you merge them, it will change them into just one commit. So then you don't have all of these commits or all of the changes, and then it's useful when there's a lot of fix, test, fix again. Is it gonna work? Bloody pipeline, That's at some point, we've all been there, and this is where you really want to use squash commits, because otherwise your boss is gonna see all of this.
It really comes down to like anything like coding practice or anything else. It just depends on what your organization style is. So like Andy and I argue about this in the PowerShell repo all the time. Like Andy likes tons of commits because you can see the history, and we're big on merge commits because sometimes we have dependent branches. And if you do a feature that's dependent on something else, you have to change something there, and you do the whole rebase thing, it becomes a nightmare. Whereas if you just do merges, Git is designed to do that stuff. But if you're not really smart about how that stuff works, you normally are more likely to get yourself into trouble than not. But if you get really good at Git, merge commits can actually save you a lot of work with a lot of complicated dependent branches. Most people don't worry about any of that, so don't worry about it. I personally prefer is that I make a feature branch. Hopefully it's pretty short-lived. I do all that kind of stuff. There's actually Git has a feature called fix up and auto squash, where you can have a couple of things where when you're doing that try again, it has an automatic thing that it can put in there, and then you just run one command and it'll just squish it all together without you having to do an interactive rebase. It's really nice. It's called auto squash. You can look it up. It's probably good. But I personally do do that. Do as many commits as I can because I have that plus timeline because I screw up all the time, and so I can go back one way or the other to get what I screwed up or accidentally deleted or whatever. And then before I submit it for review, I usually squash it to one. But then any reviews that happen after that, like we have discussion of the pull request, and like, okay, I'll fix that, all of that stuff stays. And then at that point, depending on your company, some people like one commit per pull request. So like the history of main looks really nice. Like every commit ties to a pull request, and it's easy for managers to see. Some people like multiple commits per pull request. It just depends which you guys prefer. The pluses and minuses.
It's a maturity thing. So it depends on the maturity of your team. Sometimes you will fix, and it's not necessarily a good practice, but sometimes you will fix 2 or 3 things in one PR. But maybe there's different issues. So fix issue 201, and that will be one commit. Fix issue 202, and that will be the second commit. And then that will go into one pull request. Not necessarily a good approach, because it should probably be different pull requests. But at the same time, that's one of the reasons you want to have more than one commit and not just squash them and things like that. It depends how you prefer it. But when you have this question and when you wonder, what's the best way, like that means you're already quite mature with your team in the way it works. And there's so many possibilities. This is how to get started, I would say, and then not have a problem with Git saying like, there's so many conflicts, we can't do this, we need to delete the branch and start again. Any other question?
Okay, I have one. I guess what I'm curious about, this is for the room, I guess. What I'm curious about is, I guess, kind of 2 kind of issues I'm dealing with. One is trying to start to use Git and collaboration tools for like our PowerShell development in our team. Like I said, we have maybe a big repo, and we haven't really done it. And maybe not really having a lot. We do a lot of standalone scripts, not a whole lot of modules. But the whole figuring out, I think we are going to move to get more mature, move to maybe PRs for our PowerShell. But some of the questions is around like using this kind of process for PowerShell development. I think it's always been a thing that seemed kind of overcomplicated for what we do. So trying to figure that out. The other part of it, specifically you talk about here, don't manage deployments through branching. So also, in helping with our .NET team, They currently don't use Git. Trying to encourage them, and we're gonna eventually move to Git, but now we're using Team Foundation.
Okay.
Yeah.
And they do separate branch still. It is still supported. It's in Azure DevOps. You can no longer create a new organization that supports it, but if your existing organization supports it, you have it.
That tells us something.
Yeah. And they have different builds they run different builds for different environments. So they have the dev build, QA build, pod build. Technically, they don't have pod builds, they have demo builds. But this idea of not promoting, through the
artifacts through the ring.
So just wrapping my mind around that, kind of just for that team as we move forward, as we have discussions to talk about how to get over to Git. What does that deployment scenario look like? Not talking about maybe a PowerShell module, but more talking about what does that mean? Is that separate, not separate repos, but separate. If you want to create these artifacts, we already do run separate builds for those artifacts, so would that be a separate repo for each environment?
So congratulations, you're in the engineer answer. It depends.
Yes.
There's all kinds of different strategies for this, and very few of them are wrong per se. So my opinion is that, like in that situation, if you aren't doing any kind of long-term support, like if your application is not being deployed to customers and you have like a version 1.0, a 2.0, a 3.0, if you're more of like a SaaS thing where you just have your one, dev, prod, etc., then what you do is when you do your build, like your main build is like sort of your dev build. And so sometimes, it's because in .NET the concept is more like they have one thing that has all the telemetry stuff in it, and then they have the one that's the lean, mean, doesn't do anything, it's just built for production for speed. So you can still build both of those as part of each commit. Again, you have all these resources. You can still build both the dev version and the prod version in the same commit. And so they take the dev one, put it in the dev system to catch bugs early, debug it, see that kind of stuff. Okay. And then the main one that would go to your pre-prod, your dev, your test, and event, your rings, your pre-prod, prod. You slowly promote it through. And if anything goes wrong, you have the dev build to then throw in one of those environments. Or the best way to do this is with sidecars, but that's a whole other thing going by that. In short, as far as how you manage your deployments, there's a lot of different ways you can do that. You don't want to so much track your source of truth through branches, unless you're doing a different type of process, because as I said, it's like the ideal thing is that you have this one artifact that's tied to one commit, and so everybody knows when they get that commit, it's got a certain hash, maybe it's signed, whatever, that everybody knows exactly again, the reality of that code is the reality here in the source, so you can go back and find the issue and not worry, is this one tied with this, or is this one tied with that, or which branch are you testing with, etc. If you do multiple builds on different branches in different environments, now you get into branch hell of trying to merge, and you get merge commits, conflicts, and all that kind of stuff. So managing those artifacts and how they deploy is generally not done like in the same repo. You can do a separate deployment repo. This is where like Bicep and Terraform comes up. There are ways to do it in the same repo, but the other thing too is it can just be the way that your actions run. We have to get out of here.
Yes, and I would take it even more simpler. When you get to those questions, there's many ways of doing it, and then it depends of what you want to achieve. And then depending of what you're building, how you deploy, what's your logic, then you have many different approaches. And then maybe you want to hide some of it, or maybe you want to just push it.
Maybe a good strategy to start out with is what gives them what's the most closest to their current process?
It depends.
The best thing for you would be to start with the CI part. Get the move from CFS to Git, and get however they build their artifact, the piece of software that then deploy to systems. Get all that so that they're doing that in Git. Then you can now take that thing and then put it in their own way of doing it. Where it's a manual process, it's still in CFS, but you just change it so instead of the source controller comes from that artifact. And then once you get there, then you can then mature the process from there.
And thank you.
Thanks.